Good morning, good afternoon, good evening, everyone, wherever you may be joining us from. Thanks for attending our webinar today on the smart utility. Where are we heading? Practical overview is going to be led by Pete Perciavalle. Just a few housekeeping items first. You will be muted during the presentation, but you are welcome to ask questions at any point using the GoToWebinar questions option. I will read those at the end with around 15 minutes or so to go. I will also give you the ability to unmute yourself with about 5 minutes left. If you'd like to comment or ask a question live, you'll have that ability as well. For those that are interested, there will be a follow-up email, usually within a week or two, with a certificate of attendance that you can use to submit for professional development hours with your local agencies. And with that, I will turn it over to Pete to take it away.
Thank you. My name is Pete Perciavalle. I head up innovation and digital water for our water teams here at Stantec. I am in Irvine, California, where the weather's great, and spent 10 years in working with product type solutions at Westinghouse and 20 years as a consultant. Today I want to share some of the lessons learned and some of the insights deploying digital over a 20-year career, 30-year career. And also, I've had the ability to work in several countries with some great utility leadership and wanted to share some of those lessons learned also. Today's presentation really has a little bit of something for everybody, but it is a top-level discussion on technology and sort of the culture of technology that sort of surrounds all the mystique of a lot of the acronyms and everything that sort of flows into the digital age. I want to open up also everybody, my contact information should come out with an email after this. Please call me if you want to deep dive on any of these topics in any technology or any of the leadership things we're going to speak about, elements we're going to speak about. So I want to open up for direct communication with everybody. Thank you. So for the presentation, I want to start off with sort of what is a smart utility, and kind of apply some basic definitions to this smart utility. Next slide. So almost all utilities have started down the path of digitizing their water cycle. They've done some overflow predictions, and we've used analytics to do some pressure monitoring. We've done some digitization, and all utilities have sort of started down this path. So the concepts of digital are not totally new to the water utility, but they've been done in sort of more of a project space as opposed to a systemic space. So with this definition, next slide, please. I want to start with kind of a definition here. So a smart utility is really an organization. It's a group of people doing work a specific way and working on assets. So that's the smart utility, but the smart utility is really set up to deploy and use various technology solutions, devices, platforms, and here's the flood of acronyms, LIMS and IIoT and analytics and cloud and CMMS, automation, operational technology all come into play. But it's the combination of these, the smart utility and how it's deployed and used in the technology solutions is really pointed to creating outcomes that optimize services with available financial resources, the financial resources available to really help build a progressive culture of the utility, to make the utility better. So when we look at this, we look at it through the lens of, next slide. We're going to look at it through this lens of technology solutions. What are the technology trends? What are some lessons learned from the past that we can apply to the future? And we're going to talk then about sort of the culture, and then we're going to discuss a couple of use cases moving forward on how on some of the applications that we've developed. Next slide. So looking at everybody's heard of Industry 4.0 and the industrial revolutions. Well, Industry 3.1, we brought mechanization and steam power, and Industry 2.0 way back when, we sort of began this whole industrial revolution around mass production. Assembly lines were put into play. Industry 3.0 and 4.0 is where sort of the computer revolution began. It's where we began to take analog computers to digital computers. We began doing automation of machines and applying these and developing electronics to support them. Relays and control system, boxes of relays became PLCs in Industry 3.0. Industry 4.0 is where we are today, where we are now not only automating the machines that are out there, we're making the machines communicate together, creating cyber physical systems, and create with a much more robust set of outcomes that we can produce. But we need to think differently for Industry 4.0. And if we look at this through the lens again of these three waves of computing against these two industrial revolutions of 3.0, 4.0, we see some differences and some disruptions. And when I speak of disruptions, IT has a tendency in tech, big tech uses this word disruptor. These are positive disruptors. We could call them enablers at the same time. So in wave one, we had this sort of project Industry 3.0 kind of process of project-based automation. So we would build a project, we would put some controllers on the plant floor in play, and we had PCs, group PCs that people would use, and I'm certainly old enough to remember that, where there was a sort of group PC, but you had a mainframe computer on your desk. Well, the personal computer really kind of disrupted that in wave one and made computing horsepower at the desktop. Wave two came along, and with the disruption of sort of ubiquitous networking, where everything was connected together with the old blue hose Ethernet, and Wi-Fi was actually even part of wave two, networking communications became much more robust. And the plant floor, we were able to connect plants together, unit processes together, and really automate plant floors at more of an enterprise level. In the IT side of the business, we were able to roll out ERP and a whole bunch of different applications using web interfaces. In the IT side, email became sort of a rite of passage at the desktop. In wave three, we have a whole bunch of new different disruptions or positive disruptions or enabling technologies at our fingertips. We have large ability to communicate through multiple different sensor sets, and digital platforms, cloud services are now at our fingertips for tools and at a level of affordability that utilities can take advantage of them. So Industry 4.0 really requires a different look at how we do business. Next slide. Also, utility directors, and this came from the Water Research Foundation in a survey. We talked about the number one thing on a utility director's mind is aging infrastructure and the physical infrastructure that they deal with. No surprises there. But if we look at the cluster that sort of follows that, all of them have digital components. This is becoming more and more important in meeting utility goals. So it's at the forefront of utility directors' minds. And we sort of started in Industry 4.0 this concept of slapping the word smart in front of every noun we could possibly think of from smartphones to smart transmitters to smart devices out in the field. But this is becoming more and more of a priority to get the efficiencies of the utility in play. Next slide. So Industry 4.0 offers us a whole bunch of tools out there. We call them disruptive technologies, but they are really available technologies. We've got IIoT and sensors. We've got 5G communications enabling promising much faster communication speeds and more reliable communications. We have big data, we have cloud computing. Certainly the cost of these services has gone down. Virtual reality, augmented reality, and wearables are part of our everyday dialogue. This technology is all interesting and useful, but what really has made it useful is the tech has matured to a level for water, which water is critical infrastructure, whether it be clean water or dirty water. It's at a reliability level that today that meets the requirements of that critical infrastructure. It's become affordable, and it's also validated by our consumers more and more in city council meetings, in the ratepayers vernacular is virtual reality. So we see this being validated by consumers, but consumers never in Industry 3.0 went, I need a PLC. So these technologies are much more visible to the end users of the tech. And I threw a couple of innovation triggers. I always read the Gartner stuff, smart dust and whatever human augmentation it's coming as innovation triggers in the future. Just threw those in for fun. Next slide. So promised a couple of lessons learned along the way. Number one lesson learned from Industry 3.0 is get the right mental model in place. I have uttered these phrases over and over in my career in the 90s and early 2000s about data silos. Data silos, breaking them down, stopping the stovepiped data silo, and let's build data warehouses and sort of let's build technology and they will come type mentality. Well, if we look at that, and I described this, and one of our partners on a WRF study, a gentleman by the name of Cello Vitosevich, actually said this, so I kind of borrowed this from Cello and need to credit him. The problem is they were never really silos. They were icebergs. And we always led with this technology kind of leadership. We always said, let's build the tools for the department and we'll address the business process and people change elements as we build tools. And the business outcomes were always secondary to the tech. And they were sort of more department focused. So it created these collisions below the water of the iceberg itself because the tech led it. This led to, next slide. This led to a sort of departmental project approach. And these project-based systems did work for the direct user, but the data sets that were built for this, a SCADA data set, and we've all been subject to this. We have a SCADA upgrade, we have a billing system upgrade, we have an enterprise resource planning upgrade. The data that is generated by these different projects and department level projects, we could rarely leverage. We could, we had to build things to make those data sets available. So to be able to monetize, whether that's in savings or, that's in sort of a direct revenue perspective, to be able to monetize this data to create a better outcome was rarely realized. Next slide. So what we ended up doing is we took a step back and we said, well, gosh, let's start integrating these systems together. And this slide in particular is kind of comical because I've used this with clients historically. And I had one client jump up and when he saw this slide, say, would you like to see what mine looks like? And he showed me kind of his multiple arrow diagram. And we sort of had a good laugh about that. But the lessons learned here, this is very expensive. To create this system level integration with things like data warehouses and servers and everything is a expensive proposition. It takes a lot of times years to implement, and it is very vendor dependent. When we do one upgrade to a certain element of this, multiple points of integration becomes very expensive. Systems integration is an expensive proposition. And oftentimes we don't get to see within one mayoral term the innovation. It takes that long to get some of these things moving. But today in Industry 4.0, we really get to take a sort of fresh perspective on this. The tools that are available, next slide, we don't need to integrate systems anymore. We can focus on integrating data. So this concept at the legacy level, and if we look at this, enterprise systems being ERP, could be your enterprise GIS, automation systems, various levels of DCS and SCADA, or different telemetry systems that are out there. A question of, is the system adequate versus ideal comes to mind when we look at this legacy layer. Can the system expose data? Can it push data sets out to be absorbed in more modern platforms? Adequate. Ideal, maybe not. But the systems today need to be adequate, need to be able to expose their data. Most of them are today. So we can begin building based off of adequate and not ideal, like we did before with systems. And we can apply some real very common technologies at the analytics platform layer to produce outcomes in months, not years. It enables a whole bunch of vendor diversity, but most importantly, this creates a canvas for innovation. So we don't have to be constrained by what the data warehouse has available. We need to be constrained by our imagination. So as we sort of change and transform in Energy 4.0, it's about integrating data systems and not the systems itself. So in a transformational concept of Industry 4.0 framework, transformation is programmatic. It's not a project. It's a cluster of projects, but it's pointed towards a common vision. So when we're working with clients related to digital transformation, it's always a program, number one, but the program has 4 basic steps. Now, some people break this down into 5 or reduce some of them down, but generally it follows a common framework. It's about visioning and building this framework. It's about creating governance, looking at the current state, where you want to go from a business outcomes and objectives of the organization. It identifies very quickly in phase 2 the use cases and how they're prioritized and what outcomes you want to produce. What are the KPIs attached to that particular use case? It identifies technical and commercial elements of the program, and the emphasis there is the commercial side because it's something that everybody forgets. We have to go out and buy this and deploy it, and through the lens of various technology companies. And it creates a programmatic model for this to be delivered. In step 3, we begin the technology journey. We begin looking at different solutions, and notice technology is in sort of step 3 as opposed to step 1. But we begin developing solutions with the best available technology. Testing and delivery is part of this. And then step 4 is a constant improvement process where we're measuring return on investment, abandoning things that aren't giving us return on investment, fail fast, and keep pushing that innovation envelope. So this is clearly a journey and is much more programmatic than leading with the departmental technology deployments. So in Industry 4.0 and in a framework like this, and when we invert these icebergs and we begin to lead with business goals and more in a more programmatic phase, we can look at outcomes first. And one example of this is in the customer care. There's no software packages you can go out and buy today that is called engage customers real time during emergencies and service interruption. This is a business goal. But when we begin to integrate data, think of the data sets that flow into this one activity. It's CMMS, it's LIMS, it could be LIMS, it could be your SCADA system, it could be hydraulic modeling. There's a vast array of data that could be made available in an Industry 4.0 framework to achieve this business outcome. So again, this is back to that data integration and quick deployment, fast deployment, getting value out of your digital investments. So an example of this, next slide. An example of this, and San Diego is a great example of this inverted iceberg. Now, San Diego being an example of an Industry 3.0 is where we started in San Diego, but the business process was clearly the inverted iceberg, where we led with some business outcomes first. Their pressures were, they needed to create through their capital programs, it was a fivefold increase in operating assets. They had to keep constant with this fivefold increase in assets, their operating budgets, and do major upgrades on their one large facility. They built 3 new facilities because the privatizers were putting pressure on the mayor and city council at the time to privatize the utility from the operations perspective. So this became very complex. But what we did is we looked at this first through the lens of what business pressures, next slide, where the business pressures came. And we looked at retooling the operations first. So operated a fivefold increase in operating budgets and with a fivefold increase in capital with keeping consistent the operating budgets. We needed to centralize the control center. One operator for 2 of the 3 shifts operates the entire new enterprise, in the future state. We needed to get reliability centered maintenance up and running in sort of a real-time fashion because some of the plants are unmanned. They don't have any operators on them on 2nd and 3rd shifts. We wanted to have all engineering records and operating procedures available with one click. And we wanted to raise the level of automation, create a higher level of automation. We're not doing remote control of an asset. We're fully automating these facilities because one operator is going to be operating them. We had to look at training of the workforce much differently. We needed to upskill the people in the labor force. We wanted to create a much more intuitive learning environment where operators not only follow the SOPs, but have a real working knowledge of anomalies. So basically, it's not reading a book about driving and reading a book about the user's manual on your car. It's how to drive. This was a get behind the wheel kind of intuitive learning with the philosophy of you're operating like you're physically there, removing all the local control rooms. And of course, we needed to deploy technology, and the operational program that this represented worked in concert with the capital delivery, where we put a whole bunch of tech in place. And one of those technologies that we built was sort of an integration layer above the DCS to support a whole bunch of new analytics to elevate this level of automation in the system. So this is where we used that inverted iceberg really the first time, and its outcomes from a financial performance perspective, next slide, is sort of represented in these pie charts. is represented in these pie charts. We took a snapshot, and this is an 18-year period, and I believe the before is around 2000, and the last benchmark was 2018. If we look at the outcome of this programmatic delivery, they were operating in an $84 million budget in 2000, approximately 2000. In approximately 2018, their operating budget was at 87 million. An accountant giving the time value of money would say that their operating budget has gone down because these are real numbers, and I haven't taken any net present values into the discussion. But they are operating 5 times the number of assets. The staffing levels are about constant, but the upskilling and just sort of normal raises of people represent a small change in the labor force, but the staffing is about constant. So great outcomes leveraging that inverted iceberg type of approach. Los Angeles, San Francisco, Detroit at some level, this has gone on. Sort of this project, inverted iceberg approach, has sort of spawned several of these sort of more transformational projects to be built. Next slide. So I want to talk sort of in summary here. A smart water system is, these are kind of key takeaways. It's a program, not a project. Smart implementations will yield a faster return on investment. And since the business goals lead the approach, in most cases, we can leverage a lot of the existing digital infrastructure. Adequate versus ideal is sort of the concept there. And it's a canvas for innovation and creativity, and properly deployed, if you have the right consultant, Stantec, to help you build something like this. It's elastic. It can grow with you as you begin to mature digitally. So in the next section of this, I want to address, next slide, please. I want to address the smart utility and really dive into some of the elements in water and where they're changing and some of the people perspectives attached to it. Industry 3.0, and we're going to look at this more through the lens of the business model, the people, and technology, with a couple of examples of where we're going with some of these core elements and how the utilities are changing. Next slide. While it is moving slowly, and it's not something that is fast as big tech, it is moving. Utilities in Industry 3.0 were really pointed at getting the lowest cost capital in the ground. Industry 4.0, we're looking at a much more comprehensive view of TOTEX, which is the combination of CapEx and OpEx, and lifecycle costing. We see changes in the way we do customer service. Customer service is not a survey necessarily anymore. It's sort of gauging the entire customer experience, the sentiment of the ratepayers towards the utility, and how affordable the utility is. So the business models are changing. Next slide. The people, we really are focused, especially with the generational dynamics working through in the workforce changing. We used to organize almost strictly around regulation and very organizational focus, org chart focus. And now it's much more consumer driven. Social equality and affordability enter into the equation in a much more robust way. Utilities were usually in Industry 3.0 built around a culture of standards and SOP. This is our standard operating procedure. And in Industry 4.0, we have tools to really build this culture of innovation. So sort of the generational priorities and the way we engage with customers from a people perspective is changing. No question about it. Next slide. Technology, the tools we have available. Enterprise business automation has sort of given way to departmental business processes. data-driven analytics versus systems integration analytics, and sort of the old days of IT and SCADA remote control has really given way to this operational technology and higher levels of automation. So, again, adding the word smart in front of everything, but there are some changes, no question about it, in the technology phase and the tools we have available. Next slide. Now, the utility director, and I have had the ability to work next to some really great ones in my career and learn a whole lot. But what I did learn for sure is utility leadership, whether it's at the director level, the executive level, or the plant floor manager of the utility, is a really, really tough job in the public. One of the toughest jobs. They're dealing with changes in environmental policy and regulations. They're dealing with mayoral and politics that ebb and flow, over a 2-year, 4-year period. You have a lot of social issues in responding to workforce demographics and also the ratepayers. You have a whole changing in economic environments, do much more with less. The job doesn't come with a crystal ball, but you have to make decisions based off of data in the past, which is often lacking today in the present, on assets that could be there for 50 years, that could be in play in operations for 50 years. So it's a very difficult decisions that utility directors need to make, and with limited data sets, and these have big impacts on the utility and the people it serves. Next slide. So one of the questions I get a lot in working with these are, what are the key leadership traits that are common to a lot of these great transformational leaders that you've worked with? So I listed them here, and these are the 5. They are collaborative, a collaborative personality. They work to drive consensus, but they're not purely consensus driven. We've got to make decisions and move this stuff forward. They're innovative and experimental, but never frivolous. But sort of the thesis of this is that they break that's the way we do it kind of mindset out of the utility. They're always programmatic thinkers and not just singular project focused. They are evangelistic in their approach. Dave Schlesinger in San Diego, you couldn't enter an elevator without him handing you a brochure on ComNet. He got the word out that we're doing something transformational, and pushed that through not only the ratepayers and constituencies that he served, but through the politicians and through the staff of the organization. And they had a keen understanding of all the stakeholders to get these business goals aligned across the different departments of the utility. So utility leadership is very important. Next slide. From the workforce perspective, we looked, and this came from the Water Research Foundation, giving them credit for this. We looked at sort of the generations as they move into the water utility space. There's a handful of baby boomers hanging on. We call these early adopters to technology. Click, please. But the Generation X and Generation Y and Generation Zs have a very different perspective of digital technologies. And we nicknamed the Gen X folks digital immigrants. In other words, I was born right after 1961. And I do remember the days of slide rules, and didn't use one, never became effective on one, but I do remember those days. And what motivates this generation is good pay, benefits, work stability, generally. But if we look at the Gen Ys and Gen Zs, these become very interesting. You see something very different in these digital natives. challenging, interesting, exciting, fast-paced work environment, interesting and meaningful from the technoholics and Gen Z. They have a different mindset and motivation for their careers. You can also see in this slide that 90% of the workforce in the utility is sort of focused in this Gen X and Gen Z and Gen Y sort of space. So that 90% is beginning to work towards the right and adopt less and less baby boomers and more Gen Z. Next slide, please. So with that, on the operational layers of our business, the operators of the future, as we move up and up the level of sophistication, moving into real-time control, online analytics, and algorithmic decision-making, when SCADA systems are sort of emerging as some level of, with a higher level of intelligence, do we see a diminishing direct involvement with the assets? Is this true? Is the operator of the future more intuitive in building a different culture in the organization than I follow the SOP? Next slide. This also goes for the engineering, quote, engineering elements of the business. When we see engineers, we see the day-to-day engineering side of the business. We have BIM, we have parametric design, we have computational design, and we're automating a lot of the engineering functions. Do they have less and less direct involvement? And is this important? Is a question we need to ask. Are we sort of automating ourselves out of a job? Next slide. And this is an interesting question because I think it's a myth that we're automating ourselves out of jobs. I think we are actually building a culture that supports the people's aspirations of the Gen X, Gen Y, and Gen Zs. I think we're eliminating sort of the routine and unnecessary tasks that automation can solve. But I don't think we're eliminating jobs. A great example of this is San Diego, where staffing levels were kept constant. Within a couple of percentage of number of full-time equivalents, it's been flat. The truth is, we're automating, whether it's engineering or at the plant floor level, we're automating to create more effective, efficient, and creative jobs to allow people to focus on what matters. Turning the crank for a particular valve at midnight every night isn't really a creative job. That's an SOP-driven job. We're automating to create creative and allow people to focus on creating those business outcomes. So, next slide. So jobs are different. They're not eliminated. The smart utility automates the mundane, and it is a different job set. It is a different skill set. It creates a culture for Gen X, our digital immigrants, our digital natives and technoholics, and aligns to the motivations of those career professionals who are coming out of college in the last 10 years and new grads. But again, most importantly, we create this canvas of innovation and creativity for them to take us to the next level. Next slide. So I want to dive into a couple of just quick case studies and then open it up for Q&A. So I want to go through Atlanta first. Atlanta, a large population. They have aging infrastructure and a major population boom that they're dealing with. Through our program, our capital program, and a lot of the operational things that we've been doing with digital transformation, we've been able to save them $650 million over the past 12 years. I want to show you a couple of quick elements of those transformational programs with the smart utility. So Atlanta established 8 strategic priorities, and at the center of those is this smart utility transformational program. So the One Water program has a whole bunch of elements sort of circulating around its outside, but the hub and spoke of this is this digital program that we've launched. This is at following those 4 steps of transformation. It's a smart utility framework. They've done some pretty spectacular things. So one of the things they addressed, besides all the digital stuff that came out of this, they've set some pretty lofty financial goals and outcomes. But one of the 2 interesting ones that I find most compelling here is they really began to create a formal process of change management to better prepare their people along the lines of their strategic priorities. And it includes the digital elements of the 2. So it's an employee journey mapping to create these careers in the spaces where people want to build. And this was part of their program, wants to build their careers, part of their program. Next slide. And one of the really interesting areas is, and this is a huge shift in mindset, is they really focused on how customer service is evolving in the utility to create a much more intimate customer experience, and looking at the sentiment of the utility. And they've mapped this out into a set of tools. We've mapped this out into a set of tools that really helps them understand the people that pay the rates. So this is a really interesting concept in customer service to improve the overall sentiment of the utility themselves. Next slide. And of course, nothing's fun without a little bit of technology. We deployed, for example, one of the technology, in the forefront of technologies looking at spills. They had big issues with sewer spills over and over, and we deployed a sensor network and a suite of analytics to better understand where we see issues in the sewer system, but most importantly, these analytics proactively predict where and how we should be doing maintenance in the system by looking at, it's a fairly complex set of algorithms, but it looks into the sewer systems and makes the predictions before the spills happen. So this is an example of overflow management and bettering that service level to reduce sewer spills. And we've had great success for this. At any given time, we're at 20 to 30% reductions just off this one simple set of analytics. In the UK has adopted a lot of these overflow analytics. As a matter of fact, Atlanta started with 3. We had Atlanta, and we have now 3 clients deploying these overflow analytics. But this one's a little bit different. The UK keeps, from a client perspective, we keep these confidential for these UK clients because of the way they're regulated. But one of the regulations they have in place is a 50% reduction in sewer incidents, sewer flooding, but this is at the residential property level where sensors don't exist. So this adds a bit of complexity because we're going from the sewer into the residence itself, and we're trying to make some predictions. So using data analytics and sensors, but first of all, a set of analyses tools we had to build. Where are the most at-risk areas? We identified those based off of a set of geospatial distribution and rainfall data. A whole bunch of different data sets came into this. But we identified the areas and deployed 1,400 sensors to look at residential property flooding and where we're most likely to see that. We've had great results from the prototype system to achieve that reduction right out of the prototype. And from the prototype, now we're adding an additional 3,000 sensors because of the success of this and the reduction of flooding at the residential level. Next slide. We have other tools looking at financial planning. We have a tool set called FAMS. And I always like to sort of characterize this as sort of a parametric financial design tool, where we can model multiple scenarios and looking at different cash flow forecasts. We can consider things like projecting and revenue of the utility, the expenses, looking at different levels of service, different capital plans, operating structures, and a scenario-based tool. We can integrate this into Oracle and SAP general ledgers, where we can actually look at the progress towards the current financial plan and make adjustments to those financial plans. But this really allows us to create these different scenarios to look at the impacts of these financial plans through the lens of financial performance and through the lens of affordability. And the affordability factor is becoming more and more important. Affordability, and we can look at a financial scenario from the ratepayer's perspective by zip code, by census tract, and we can look at that as a function of time and look at how that particular rate case, for example, is going to impact different zip codes in different areas in the service area. So this really kind of gives us a good glimpse of how that financial plan would engage the customers and impact the customers in the future as these affordability metrics become more and more important. Next slide. This is another interesting analytic, and this has been adopted by several of our clients, and also the Canadian government's looking at this, but looking at this similar to Atlanta through the lens of customers, using social media to improve customer engagement. We intercept Twitter, we intercept and absorb and consume Facebook feeds and news feeds. We process it through natural language processing using machine learning and text analytics, and do some sentiment analysis to better understand the customer engagement, the customer segments, whether this is big pipes or small pipes, residential, to understand what are the trending topics, what are the key customer issues. Up and to the right, we can see sort of an overview of trending elements, customer issues over a function of time, the geospatial view, but the second down to the right is sort of where that sentiment index, in giving this data context and understanding the performance of the utility from the eyeballs and from the data of the customer themselves. Next slide, please. I want to plug two projects in closing here. WRF Project 5039, we are actively working with 70 utilities out there to define this smart utility and creating a maturity model to better understand where the utility is and what the universe of options and maturity are to go and where we can go with it. And there's another one, it's a WRF project called LIFT. And if you want to go to a place to look at best practices associated with maintenance, associated with customer service, there is a full mapping of hundreds of different processes, best practices, processes in this UAIM project that is being led by Cello Vitosevic, coming from Metropolitan Water District here in San Diego, that is sort of the host of this utility analysis and improvement methodology. So with those two projects, I want to just say, keep an eye on them and engage. Lessons learned: simple digital utility is not a collection of IT projects. It is a transformational process that people need to be in the heart and soul of, and people change. It's a shift from this sort of systems integration to a data-centric architecture, and it is a journey, but it is a journey that can get some quick wins and some value out very quickly out of the right transformational model. And with that, I want to open it up to questions.
Great, thanks, Pete. Much appreciated. We have some questions here. Just want to remind everyone you can use the questions option to go to webinar, and I'll unmute your mics here in just a couple of minutes if you'd like to ask something live. First up, Pete, there's a question about San Diego. There was a graphic up where it talked about the staffing stayed fairly constant despite an increase in cost from 20 to 29 million. Can you explain how that was accomplished?
So a lot of the 20 there, when we looked at the people, they were sort of averaging around. The number was around 330, and it would sort of ebb and flow. Maybe 5% above, 5% below over that period of time. We may have caught it at a bit of a peak. But, if you look at the cost and raises of those approximately 330 people, that makes up a big portion of that increase. But also they brought on some folks that sort of command a couple of higher salaries along the way that go into that mix. It wasn't you're hiring a different skill set into the utility, so that made up a good portion of that increase. Sort of, plus it's California and everything's kind of expensive in California. But that was the majority of the uptick in cost relative to sort of that generally flat curve.
Okay, great. Thank you. Another question specific to San Diego. You mentioned something about a higher level of automation. What do you mean by that, or could you provide some examples?
Yeah, I'll just briefly, whenever I say higher level of automation, we're moving away from sort of automating the asset itself, the start, stop, on off of a pump. And we're looking at that pump in sort of a full mass balance context, such that minimizing the operation of the unit process, minimizing the operation of the utility itself. Since we were going to one operator, we really needed to get into a much more automatic mode on these unit processes. And I'd like to ask Joe Cullen, who was present also and one of the developers of some of these more sophisticated algorithms, to jump in here and maybe give a minute or two on some of the examples of these more sophisticated automation platforms. Joe, you're muted. There we go.
Hi, this is Joe Cullen. I worked on the San Diego system for a little over 17 years. So we had lots of opportunity to try to make some improvements. And we recognized, especially on something like a filter backwash, labor being of using our labor in the best way possible. For example, on the filter backwash, we really didn't have the luxury to have people just watch it and just dedicated filter backwashing duties or filter duties in general. So the original design did have a pretty robust automation, but it was just basically classical control with the sequence. It wasn't very intelligent, just simply used empirical set points from observation when the plant started up to set the backwash flow set points, or scour set points, the time set points, the filter initiation set points. And over time, I mean, of course, an operator could spend some time, if you had the staff, to go out and continue to tweak those, hopefully to find some optimal parameter. In San Diego, what they decided to do to try to save some energy and also to optimize the filters and then create a more robust filter backwash scenario, as the plant wasn't manned for 2 shifts. What we did was we inserted some instrumentation in the filter itself, so we could use them for machine learning and some model predictive control, try to tune in better set points. And that was achieved by using in-filter turbidity measurement, in-filter media expansion, and the filter, obviously the filter turbidity, effluent turbidity, And those three parameters in general could be used on a big data from a big data perspective over time to try to learn a better or predict a better set point. And I want to stress this is really a passive closed loop type control, meaning you are striving to converge to a more appropriate set point. You're not simply just looking at a filter backwash scenario, watching what you think is taking a snapshot of what you think is where you want to be and applying that. That would be a mistake. That's not really what adaptive control is about. Through that process, they, in particular, the South Bay plant, they did gain some significant savings, energy savings. You're spending less time backwashing, you're getting better backwashes, and you're delivering more Title 22 water to the customer. And since the backwashes were more consistent, they were more reliable. So you didn't have the situation where a filter wouldn't drain because somebody ignored it, and you couldn't drain the filter quick enough to get it back online. And also you reduced the chance of wasting your anthracite media. These are anthracite media filters by blowing too much air scour and backwash flow at the wrong time. So it did make an improvement. And I do want to stress these adaptive control systems, they have to be designed so you can leverage the larger data sets. And also you do want to design them in a way that they actually do learn. I mean, you really do want to employ the advanced techniques of model predictive control, machine learning, and nowadays it would be A&N, artificial neural networks as well. But it was a success, and it's still ongoing.
Thanks, Joe.
Great. All right, we have a question around just in general, are there other utilities besides San Diego or Atlanta where we're developing or implementing smart utilities? That's a question from Petra.
Yeah, we're seeing growing emphasis on getting these transformational programs together. Working with utilities, we're working with several underway. A lot of these concepts we're working in the UK with, and in North America. We have a growing request. We've seen just 2 RFPs. We haven't heard if we won yet, but even building an innovation culture, we've seen 2 RFPs we've responded to on helping utilities kind of leverage and build that shift from the SOP culture to the innovation, to an innovation culture. So there's a lot of interest from the utilities in sort of building off of some of the concepts from Atlanta moving forward. So yeah, lots of opportunities out there.
All right, we're a few more questions coming in here, but I'm gonna give everyone the ability to unmute themselves. I know at least one individual would like to ask their question.
Okay. Hey, Pete, can you hear me?
Yeah, your mic is really noisy though.
Okay. Can you hear me now?
Go ahead, we'll give it a shot.
Okay, yeah. Firstly, thanks, Pete. This is such an awesome talk. And this is Nishant from Mumbai. I'm a graduate student from UCLA. I was just curious about what kind of intelligence goes behind the predictive spill prevention systems that you were talking about. And yeah, I'm someone who has been working on using water systems of late. So I was just curious about that.
I'm having a really difficult time hearing.
Yeah, I think that was this didn't come through very clearly. Nishant, if you want to maybe just put your question into the questions box, we can follow up with you. Unfortunately, your microphone is too noisy.
Hey Ryan,
Yes,
I want to make sure everybody has my contact info.
Sure.
And invite everybody to, with questions or ideas, or if we want to dive into, how an Azure environment would be deployed to support this, and all the technical or commercial questions that come along. I want to invite everybody to email me, directly, or feel free to give me a shout too. I'm interested in building, interested in growing this portfolio, and even just to chat about it and get some concepts out. I'm always interested in learning too, and
I just
sharing
put
experience.
a link to your information on stantec.com, Pete, in the chat. So anybody that would like to follow up with Pete, his email and phone number there are in that link.
Excellent. Thank you.
All right, Nishant, if you want to give it another try, go ahead.
Yeah. Hey, Pete, I guess you can hear me
Much
better right
better.
now.
Yes.
Yes.
Sorry about that. Yeah. Firstly, thanks for such an awesome talk. Like, this is Nishant. I'm a graduate student at UCLA. I was just curious about what kind of algorithms that goes behind these predictive spill prevention systems that we are talking about. Like, I'm someone who has been working on intelligent water systems of late, so I was just curious about that.
There's a broad range, with the, some of them are stuff that we have developed proprietary, that we obviously, share with our clients. But, Joe Cullen's probably, well, he's closest to the programming side of it. We'll use, particularly in the operational contexts, we'll use artificial neural networks. We usually try to, because we're dealing with such a huge amount of data when we get into the operational side, it's high in volume, and it is also, pretty noisy type stuff that we get. A lot of times we'll do some type of corrections up front, depending on where the use case is on that noisy data.
Makes sense.
So like with sewer levels, if you look at sewer levels and trying to predict sewer overflows, the sewer data comes in, and we're trying to do a 90-day average in an environment where we're looking at a diurnal kind of effect, so we can compare what is normal upstream and downstream in the sewer. A lot of times we'll just use a simple averaging thing when we get a bad data feed. And what we usually see in levels from the data feed is something crazy like 0, which obviously it didn't go from 5 feet to 0 in 2 seconds. But so we'll do some smoothing there. But in that same kind of vicious data stream, we could see a 16-bit integer and 32,767 from a strange reflection that comes from the ultrasonic. So we reject those when we're looking at sort of these broader analytics of making predictions. But those zeros and 32,000s in a different use case of the actual sewer itself are meaningful. So is the sensor fogging. So we apply a different set of analytics, and for some details, Joe's probably the best at where we apply what and when. But if that answers your question in general, great. If not, we can dive into some details separately.
Yeah, sure. That answers that. Thanks.
Okay, thank you for the question.
I know we're a little over, but I have one more question here I'd like to ask Pete. I think it's a good one. And then anyone that didn't get their question answered, we'll just follow up with you offline, or like I said, you can contact Pete. But Sandra had a question about differences in models or approaches needed in smaller, mid-sized utilities versus larger, because we've mentioned Atlanta and San Diego, which obviously are pretty large organizations, but how does this apply to a smaller utility?
Well, the deployment of these digital solutions, I've referred to it as elastic. Getting these use cases out in front, everything that we are developing and moving forward in the market is we try to keep it scalable to the size of the market, number one. But if you're rolling out an Azure environment, there's a good chance that you may have Azure in your utility, even if you're a smaller utility, because it's really just a Microsoft. It's not just, let me rephrase that. It is a Microsoft sort of platform that we can use. So you may have bits and pieces available. The question of adequate versus ideal, most utilities have SCADA and they're probably scaled to, if you're a smaller utility, you're less likely to have a sort of massive SCADA deployment in place. So we can leverage a whole lot of that existing infrastructure. So it scales really well. And the platform services are relatively inexpensive. If you understand what not to do in the Azure environment or in Amazon Web Services, as an example, we try to take a lot of that expensive pre-processing out and out of the equation to keep these things to be extremely affordable, whether it be for something as large as United Utilities in the UK or City of Los Angeles, and make them scalable for smaller utilities out there. So we think of in that planning cycle, and we could go into some details or examples separately, but we really try to keep that data pre-processing and at a minimum to create that affordability factor for everybody across the spectrum.
Okay, good. Thank you, Pete. We appreciate that. Thanks to everybody that stuck around with us here. Really appreciate it. Hope to see you on a future webinar. And again, if you have questions, feel free to reach out to Pete directly. And I hope everyone has a great day. Thanks to the presenters.
And thanks everybody.
Yep. Okay, thanks Pete.
Thank you.
Bye, everyone.